My name is Justin Lara. This is the final presentation assignment for Aviation 326 Commercial Flight 2 at Liberty University. The prompt for this presentation is to make a video covering a commercial training topic. The topic I chose is commercial training maneuvers, and I came up with scenarios to use for the presentation. In this flight, we'll be practicing commercial maneuvers to refine our skills for the upcoming commercial check ride. These maneuvers will be performed at a point within 30 minutes that is free of obstructions and dense traffic. Maneuvers we will be performing include steep turns, steep spirals, chandelles, lazy eights, and eights on pylons. I chose to discuss this topic because most of commercial training is the same as private training. Although for a commercial rating the pilot is expected to perform those tasks at a higher level, they are not new concepts. The commercial maneuvers, however, are new in commercial training. While there are maneuvers in private pilot training and some of the concepts learned carry over to commercial maneuvers, the commercial student is introduced to these maneuvers for the first time as they prepare for the check ride. I have personally found that some of these maneuvers can be challenging myself. It is extremely important for all commercial flight training students to understand these maneuvers because they help develop mastery of an aircraft and are a required check item per the Commercial Airman Certification Standards. As with any flight, we need to consider the PAVE checklist. This should be done before the flight but revisited throughout as things change. As the PHAC explains, P stands for pilot. This includes competency, condition of health, mental and emotional state, fatigue, and other variables. I'm in pretty good shape for this flight myself. A is for aircraft, including performance, equipment, and airworthiness. We'll need to go through a pre-flight checklist with the aircraft to ensure it meets all the maintenance requirements, check to ensure it has all the required documents, do our various calculations, and more. I'll also consider if I have the necessary familiarity with the systems and instruments. If I've only flown a round gauge plane for months, I probably shouldn't hop into a G1000 Cessna expecting I'm still proficient in flying the thing. V is for environment. We'll consider weather, air traffic controls, nav aids, terrain, takeoff and landing areas, and surrounding obstacles. I like to do these flights over the hills just east of Reed Hillview Airport where my flight school is located. Clouds are often an issue in this area. Although it may be a fairly clear day, the lifting force created by wind flowing over the hills often creates clouds along them. While flying around while maintaining legal cloud clearances or through an IFR flight plan is typically just fine for a cross-country flight. Maneuvers require quite a bit of space free of obstruction with plenty of room to see other traffic coming. Finally, E is for external pressures, which includes things external to the flight that may impact decision making as it relates to the flight. It may seem that there isn't any for this one, but when you have a progress check or actual check ride approaching, it's easy to become willing to accept additional risk to ensure you will be ready in time. The Airplane Flying Handbook explains that steep turns is a 360 or 720 degree turn done one or more times with a bank of 45 to 60 degrees. The maneuver develops the pilot's ability to smoothly control the aircraft, maintain situational awareness, divide attention, and continue scanning for hazards. When an aircraft banks, it uses the horizontal component of lift to turn. Higher G forces are experienced due to the vector addition of centrifugal force and gravity. The higher G forces may make it more difficult to move and maintain orientation. The maneuver should be performed below maneuvering speed to ensure it will stall before exceeding the design load limit. Additionally, pilots must be aware of the overbank tendencies that, when at high bank angles, cause an aircraft to continue rolling in the direction of bank unless deliberately acted upon. Using power and/or trim may help to relieve control pressures required to maintain altitude with the loss of vertical lift. To complete the maneuver, according to the commercial ACS standards, clear the area, establish the manufacturer's recommended speed, or an airspeed below maneuvering speed if unavailable. Roll into a coordinated 360-degree turn with 50 degrees of bank. Roll out and repeat the task in the other direction. This should be done while maintaining plus or minus 100 feet, plus or minus 10 knots, plus or minus 5 degrees of bank, and plus or minus 10 degrees of the desired heading when rolling out. Common errors for this maneuver include not clearing the area, inadequate pitch control on entry or rollout, gaining or losing altitude, failure to maintain constant bank angle, poor flight control coordination, ineffective use of trim, ineffective use of power, inadequate airspeed control, disorientation, performing with reference to flight instruments rather than outside visual references, failing to scan for traffic throughout the maneuver, starting the recovery prematurely, and failing to stop the turn on the desired heading. Steep spirals are a gliding turn where the pilot maintains a constant radius from a ground reference point. It allows the pilot to rapidly lose altitude while staying over one spot and could be useful during emergency landings. While like an emergency descent, the reasons for using the maneuver differ and commonly done with a different airspeed and configuration. Operating at idle in a glide could result in excessive engine cooling, carburetor icing, and spark plug fouling. To prevent this, the throttle should be periodically advanced. To complete this maneuver, clear the area, select an altitude sufficient for 3 full 360-degree turns, then establish and maintain a steep spiral. Without exceeding 60 degrees, wind drift correction should be used to maintain a constant radius. The pilot must divide their attention between maintaining airplane control, avoiding traffic, the ground track, and staying coordinated. The maneuver should be done with within 10 knots of the desired airspeed and discontinued by rolling out within 10 knots of the desired heading no lower than 1,500 AGL. Errors for this maneuver are often associated with not clearing the area, inadequate pitch control on entry or rollout, not compensating for wind with bank, poor flight control coordination, ineffective use of trim, inadequate airspeed control, becoming disoriented, performing by reference to flight instruments rather than visual references, not scanning for other traffic during the maneuver, and not completing the turn on the desired heading or reference. Chandelles is the one I'm having the most trouble with because I like to stall the aircraft during the maneuver. A chandelle is a max performance 180-degree climbing turn that begins from approximately straight and level flight and concludes with the airplane in a wings level, nose high attitude just above stall speed. Left turning tendencies have a greater effect at low airspeeds with higher power settings and require the increase in right rudder pressure. The pilot must clear the area, select an altitude above 1,500 AGL, then establish the appropriate configuration, power, and airspeed. The maneuver can be split into two stages, prior to and after the 90-degree point. Begin with a 30-degree bank while simultaneously adding power and pitch for a coordinated climbing turn. In the first half, bank remains constant while airspeed decreases with a gradual increase in pitch. The pilot then gradually rolls out of the turn at a constant rate from 90 to 180 degrees while maintaining a constant pitch. The maneuver is completed by rolling out within 10 degrees of the 180-degree point just above stall speed and not actually stalling, then recovering without losing altitude. Common errors include not clearing the area too low of an initial bank resulting in a stall, that's me, too high of an initial bank resulting in reduced performance, increasing bank after establishing 30 degrees, failing to begin recovery at the 90-degree point, continuing to increase pitch beyond the 90-degree point, not reaching the 180-degree point when wings are leveled, too low of pitch during recovery resulting in high airspeed, control inputs not being smooth, not staying coordinated, stalling, beginning steep turn rather than climbing, not scanning for hazards, and primarily using instruments rather than visual references. Lazy H are the only maneuver in which flight control pressures are constantly changing and develop proper coordination of flight controls across a wide range of airspeeds and attitudes. In a Lazy 8, altitude changes through two 180-degree turns. Outside references are used to ensure turns are symmetrical. As airspeed and bank is adjusted, the required rudder pressure will change as well. It is important to be ready for this to maintain coordinated flight. Lazy 8s are done by clearing the area, determining the desired altitude greater than 1,500 AGL, and establishing the recommended entry configuration, power, and airspeed. There should be roughly 30 degrees of bank at the steepest point, a constant change to pitch, roll, and airspeed, altitude within 100 feet of the entry altitude at the 180-degree point, airspeed within 10 knots of the entry airspeed at the 180-degree point, and heading within 10 degrees of the 180-degree point. The pilot must maintain coordination and repeat the process with consecutive symmetrical turns in alternating directions. Errors for lazy 8s are often a result of not clearing the area, the maneuver not being symmetrical at the 180-degree points, poor outside references, ineffective planning, not being in control at the top of the maneuver causing the nose to drop, inadequate airspeed and bank, control roughness, uncoordinated controls, stalling, doing a steep turn instead, failing to scan for hazards, and focusing primarily on instruments rather than visual references. When performing 8s on pylons, altitude is adjusted throughout the maneuver to account for wind while maintaining the same line of sight from the eyes through the lateral axis of the plane into the pylon. The proper altitude for 8s on pylons is referred to as pivotal altitude and is dependent on ground speed. Pivotal altitude can be found by squaring the ground speed, dividing that by 15 miles per hour or 11.3 for knots, then adding the mean sea level of the ground reference. Bank angle does not affect the pivotal altitude unless steep enough for it to affect ground speed, but it does affect the distance from the pylon. Above the pivotal altitude, the pylon appears in front of the reference line, while below the pivotal altitude, it moves behind the reference line. The pylon selected should be of adequate distance apart to allow for roughly 3 to 5 seconds of flight in between and prominent enough to find easily. To perform the maneuver again before any clear the area. Next, determine the pivotal altitude and select 2 pylons. Then enter the maneuver in the correct direction and position using the proper airspeed and altitude. Establish the necessary bank which not exceed 40 degrees. Throughout the turn, the pilot should make smooth corrections to keep proper line of sight while dividing attention between coordinated airplane control and outside visual references and avoiding slips and skids. Common errors for this one include failing to clear the area. I've done that before on this one. I began the maneuver looking for a pylon looking at the pylon and didn't realize that an aircraft was there that would have converged with my flight path. Other errors include slipping or skidding in turns by attempting to stay on the pylon with inadequate rudder, an excessive loss or gain in altitude, a bad selection of pylons, not entering the maneuver into the wind, selecting a heading in between the pylons that fails to account for wind drift, improper timing of initial bank, abrupt control inputs, and failing to select the proper pivotal altitude. These are the references I used for my presentation. And again, my name is Justin Lara. Thank you for watching.